Hi, welcome to another video. So this is a quick demo of a cheap transmitter and receiver pair. Got them from RF Solutions down in the south coast in the UK. Had problems with my encoders and decoders, so I've just got some regular picks until such time I can get the proper encoder. So what I've done, messed about with the program. Yeah, unfortunately Microelectronica's PIC Basic Pro doesn't cater for the PIC 10F202. Don't know why, maybe it's because it's such a small package and I think you can fit 512 words. So what I've had to do is go back to my old faithful PIC Basic Pro. So what I'm doing, programming this using serial out, that's running to a transmitter, which is just there. That's the actual transmitter from RF Solutions. It's an Alpha Plus TX868. There are others available. This one's about £7. I think they do cheaper ones for £5 or £6. You get from Farnell, RF Solutions, or even Maplins. But sadly, Maplins don't keep stuff in the shop anymore. It's all sort of order overnight. Anyway, so this is the transmitter. That's the receiver. So again, because I messed up my encoder, I think I blew it up. I think I blew up the output pin somehow when I was messing about a few months ago. Right, this is the transmitter, and I've previously been using RF Solutions encoder. Hope you can see that part number there. Available from Farnell, Maplins and RF Solutions, other places. My original chip, the output's meant to come out on pin 3, go to the transmitter, and it was dead. I don't know why, maybe because I connected up to a GBS like a few weeks ago and maybe I blew it up. But anyway, so pin 3 on this chip is dead, so I thought I'll try and reprogram it. Microelectronica's software, as I say, doesn't cater for this PIC 10F202, but PIC Basic Pro does. So I've done a quick routine PIC Basic Pro. Just if looks for this button, see if this button is pressed. If it is, it sends out some serial data, and if it's not pressed, it sends out another string. So simple transmitter, 3 wires, power, data and ground. Now what I've got set up on the scope, which is important, why your transmitters and receivers have to be coded. So this is showing an off code at the moment, so I think it's a string of zeros, hence the big gap. Now, so if I turn my transmitter off, that's the receiver, that one there, picking up random RF. I think this is running at 868 megs FM, and that is coming from someone else. Maybe it's my keyboard, I know their RF, my wireless keyboard, wireless mouse, or maybe it's from another house up the road. But certainly that is not my data. So you can see it's all sort of junk coming in, so you can't just use the transmitter and receiver and hope to get reliable on or off. So what I've done, I'll show you the code. Turn my transmitter back on. There we are, so the receiver's now synchronised with that. I'm getting a string of zeros, and what I'll do, press this on button, and you see I get a string of ones. So it's inverting the signal, but that's what a string of ones look like. When I let go of the button, that's a string of zeros. And if we look at the receiver, so that's on, and then I'll let go of this. Right now, so what we've got is actually a delay. This receiver, so you don't get any false ons, depending on what you want to control. Maybe it's something simple and it doesn't matter if you get a false error. What I've done, it looks for the string of ones, and it counts, because it's all happening so quickly, it counts the ones, and every time it gets the right string, it counts 1, and then keeps on counting, and when this one gets to 100, when it's in 100 correct codes, it then turns on. So when I press the button, see if I can get both in view. I'll press the button, you'll see a very small delay. So that's on, off, so on, a few millisecond delay. And that's because this is counting to 100, make sure it sees that code 100 times before it turns this on. And then when it's off, it has to see the zeros. So that's off. I'll press on. Obviously the receiver picks it up instantly, but the decoder isn't decoding it until it sees it 100 times. Well, what I'll do, try and measure this on time. Set up the cursor already. I think that's it there. So that's the start of the on, off there. So one complete cycle, 4.28 milliseconds. So because the receiver or decoder is looking for that but 100 times, it's obviously going to take 428 milliseconds. So still like less than half a second. And you know you're not going to get any false ones. So small delay, you can cut it down to 10 counts or 2 counts. But before, when I had this off, if I turn that off and back to that, when I had looking for ones or zeros with all this rubbish coming in from somewhere else, it was seeing 1 and a 0, so that LED would flash intermittently. There you can see it's rock solid. So that's a transmitter. Good practice to stick some decoupling caps across the supply. This one's running it on a 3-volt lithium battery. As I say, this example, only this switch is wired up. The previous encoder had these 2 implementers as well. 3 wires, so that's the data out I've got coming off pin 4, data out and power and ground. So that's a simple transmitter. The receiver, haven't quite finished it yet. The proper RF Solutions encoder has got a learning wire, which I've chopped off, and an LED, so you can learn various transmitters. And press this, the LED would come on. But as I say, the encoder was blown up, so I've erased their decoder and just used a chip and programmed it in my own fashion, which I'll show you later. That's just a smoothing capacitor, decoupling capacitor. This capacitor here, with this, I was messing about, just prototyping. This is a 1K resistor charging up this capacitor, and that gives you a small delay before the enable pin on this goes high. I didn't have any smaller capacitors, so because this is a large capacitance, I've got away with using a 1K resistor. That gives me a second or so delay. In fact, what I'll do, I'll put my scope on it and I'll show you. Right, so that's power. The other side of that cap's ground. So if I take the batteries out, go back to the scope, clear the measurements. Right, so if I put the battery in now, you'll probably hear it click down. There we go, so you can see it takes a second or 2 to charge up. What I'll do, I'll slow the scope down. So that's 2 seconds of division. I'll take the battery out while that scope's resetting. Right, here we go, I'm going to put the battery in. There we go. So you see 2 seconds of division, so that's within 2 seconds before it comes up. Not sure when the transmitter or the receiver becomes enabled, somewhere along here, but RF Solutions recommend you enable the receiver after power up, so that capacitor and resistor network just giving you a small 1 second delay. Right, this is the transmitter setup, so that's a PIC 10F202, 1 switch on pin 5, That's a serial out to the transmitter, obviously power and ground, and you can see I've got the power says 2 to 5.5. This battery is nearly flat, but it's down to near 2 volts. Yeah, that transmitter still works. So that's a transmitter, easy setup, one switch. If you get the RF solutions, you'll have 3 switches. That will be the transmitter out or data out, a switch there, and one on pin 8. Give you 3 bits of data out. Right, let me move down to the receiver. It's slightly more complicated, but only slight. As you see, the receiver's got an enable pin, and RF solutions say this enable is best that this comes in after the power. So what I did, had a 1k resistor to hand, which meant I need a big capacitor. A 1k resistor that charges this capacitor up over time, as you saw on the scope. This was actually 1000 microfarad, so you could obviously, you know, make this a fraction of that value and increase it, 10k, 100k, something like that. So long as this enable comes up after the VCC, and that's the decoder with an LED on the output. So I've just got a small note there. So if you haven't got PIC Basic Pro or microelectronics software or anything like that, RF Solutions actually sell an encoder and decoder. So I'd actually bought the 2, but the encoder didn't work twice. That's the one from RF Solutions and one from Farnell. Costs just about £1.30, 35 each. Their encoder is pre-programmed, and it will give you a better transmitter than this because you have three outputs and 3 inputs, and that's it. You have a complete transmitter and receiver coded for less than £20. As I say, you have to put some sort of coding on there, otherwise you'll pick up random RF from other devices. These are the devices I purchased. This one here, the 868 transmitter, £7.27. I think it's plus VAT and delivery, but and then the receiver. This is just an extra enable pin, or it's not that receiver because that's 433. I'm using the 868, but the 433 has actually got a bigger range. I think the range on these is about 150 meters or more, and the 433 megs is even greater. That's it, that's the receiver. I've got £7. It's £7 for the receiver, £7 for the transmitter, but they do cheaper ones for I think £5 something. If you want a more powerful transmitter, look at this. I've got that other page ready. It's a 458 megs RF transmitter and receiver. Look at the range on that, incredible. Up to 20 kilometers in direct line of sight. 1 to 3 kilometers range within buildings. 1 to 3 kilometers. Well, you've got to be rich if you've got a building that big. I know they're obviously saying, you know, the higher the powers because interference, walls, metalwork, that sort of stuff, but are they powerful or what? But they're actually best part of 160 and £200 depending on which models you buy. So it's all out there if you want it. I think I found the wiring diagram, although you can vary the modulation input on these. Let's scroll down, so there's a few more pins, but simple wiring diagram, and that's for the high power 500 milliwatt output. Fantastic. So a brief insight to coded transmitters and receivers and what's out there. Maybe you're familiar, maybe you're not, but hopefully this will have helped. So I nearly forgot, you need to see the code. Right, so if I go transmitter first, so with the 202 it's using an internal oscillator, so no messing about with crystals, resonators. So this is using PIC Basic Pro Microcode Studio. Hopefully you can see all that. So I'm defining the internal oscillator. This is the option reg, which is port B pull-ups. So that's a transmit on GPIO1. and I can't scroll down because that's the end of the page. So this is the main loop. So if GPIO.0 equals 0, so that's if the switch is pressed, B0 becomes 1 1 1 1 1 1, 8 ones, else it's 0 0 0 0, that's all the zeros, and end if, so that's all that code is doing, all that microcontroller. And then it's serial out, transmitter, that's the baud rate, 2400, and it's transmitting B0, and that goes to main loop. So that's there, just that one small loop of code, 158 words. I think these microcontrollers take 512 or this 202 GAN, so if you're running PIC Basic Pro, see up there, PIC 10F202. As I say, microelectronics software doesn't incorporate this microcontroller, so gone back to my good old faithful PIC Basic Pro. Now the receiver is much the same. So defining the internal oscillator, so all I've done, receiver is GPIO pin 1, B0 is a variable byte, so serial in, RX, which is RX GPIO1, baud rate, and B0. So look, if B equals 111 string of 8, then counter equals counter plus 1. That's end if. If B0 is not equal to a string of 1s, then counter equals 0. So then if you look further down, if B0 is equal to the string of 0s, then that's turning that LED off. If the counter is greater than 100, so if the counter is seeing all these ones, the string of ones, if it sees it 100 times, it's zeroing the counter and turning the LED on. So this bit here, if B0 is not equal to, so if it's not equal to the string of ones at any point during that count to 100, it's going to zero the counter. So that's what that is. So it just gives you more security, so you're not going to get false triggers and false ons. Maybe you're going to open some gates, turn some lights on and off, or turn anything on or off. As I say, if you use the RF solutions encoder and decoder, you can turn 3 things on or off, toggle them so they switch on and off, or they'll latch on. So that's it. Hopefully this has given you a bit of insight. Thank you very much.